Hello, boys and girls. Welcome back to 5th grade math with Mr. Herring. Today, we are going to be simplifying fractions. So the essential question for today is, how can I simplify fractions before or after I add, subtract, multiply, and divide them? So today, I can simplify fractions after adding or subtracting them because right now we're working on adding and subtracting. So the first thing we get to ask is, what are equivalent fractions? Equivalent fractions are fractions that name the same amount. For example, if I look at these two circles, the one on the left and the one on the right, I shaded an equal amount of each. However, this circle on the left is only broken into two pieces, where the one on the right is broken into four pieces. So if I shade 1/2 of the first piece, that is the same as shading 2/4 of the second piece. So then 1/2 is equal to 2/4 because the same amount of the circle is shaded. If I look here, this piece, shaded part, is equal to this shaded part. Okay, so that's what makes an equivalent fraction. So let's look at it this way. If I have 3/4 and I'm trying to find out, is 3/4 equal to 9/12? Well, the way I do that is, can I multiply the numerator, that's a number on top, and the denominator by the same fraction or the same thing to get 9/12? Well, let's find out. What can I multiply 3 by to get 9? If you said 3, that's correct, because 3 times 3 is 9. Okay, so let's look at 4. Well, can I multiply 4 times 3 to get 12? 4 times 3 is in fact 12. So if I can multiply by this whole, because 3/3 is equal to 1 whole, then this is an equivalent fraction. 3/4 is equal to 9/12. If I do the skip counting method, if I count by 3's on top, 3, 6, 9, I stop at 9, and on bottom 4, 8, 12, then there's my 12. So 9/12 is equal to 3/4. Okay? Let's try another one. So what whole fraction can I multiply by 5/8 by to get 30/48? Let's see if there is a whole fraction. 5 times what number equals 30? Well, if you said 6, 5 times 6 is correct. 5 times 6 is 30. Well, let's try that. Is 8 times 6 48? That is true. 8 times 6 is 48. So then 5/8 is equal to 30/48. Let's do the skip counting method. I count by 5's on top. 10, 15, 20, 25, 30. Now 8, 16, 24, 32, 40, 48. That worked out. So 30/48 is equal to 5/8. All right, let's try a couple more in a little different format here. 2/8, 2/3 equal to 8 what? Well, what did I do to 2 to get to 8? 2 times 4 is 8, so whatever I do to the numerator, I have to do to the denominator. So then 3 times 4 is 12. Again, we can check that. 2/3, 2, 4, 6, 8, 3, 6, 9, 12. It worked out. So then 2/3 is equal to 8/12. All right. 9, they didn't give me a numerator here. I'm looking for the numerator, so I can start with the denominator. 9 times what is 27? 9 times 3 is 27, so 4 times 3 is 12. I multiply by 3/3. Let's check it. 4/9, 4, 8, 12, I can go one more, 16, 9, 18, 27, 36, 12 27ths is right there, so they are equal. Okay? What's important then is I have to do the same thing to both denominator and the numerator. All right, 10 15ths is equal to 2 what? Well, now the number got smaller, so what did I do to 10 to get to 2? I divided by 5, so I have to do the same thing to the bottom number. So 10 divided by 5 is 2, 15 divided by 5 is 3. Okay, and over here, 6 to 3, it got smaller, so we know we have to divide to make a number smaller. 6 divided by 2 equals 3, or what number divided by 2 is 4, or work backwards, 4 times what number is, or 3 times 2 is 6, so 4 times 2 is 8, and 8 divided by 2 is 4. Remember to work backwards if we have to. So what did I do to 8 to get to 40? I multiplied by 5. 8 times 5 is 40. So what number times 5 is 50? Well, the answer to that question is 10. 10 times 5 is 50. Here, 3 times 4 is 12, so I know a 4 is here. So what number times 4 is 4? And that's right, the answer is 1. 1 times 4 is 4, 3 times 4 is 12. 1/3 is equal to 4/12. You can always check it with the skip counting method. 2, 3, 4, count by 1s on top, count by 3s on bottom. 3, 6, 9, 12. 4/12 is equal to 1/3. All right? So a couple more. 2 to get to 10. I multiplied by 5. So what number times 5 is 15? The answer is 3. 18 to 6. I divided by 3. So what number divided by 3 is 5? Well, 5 times what times 3 is 15. You have to work backwards. Let's check it. Is 15 divided by 3 5? Correct. Now I count up numerator and denominator. This is that counting up strategy. So 1/4 is equal to 2/8, 3/12, 4/16, 5/20, 6/24, 7/28. All these fractions are equal. I skip count by 1s on top and by 4s on bottom. Here we're going to skip count by 3s on top and 7s on bottom. So 3, 6, 9, 12, 15, 18. On bottom 7, 14, 21, 28, 35, 42. All of these fractions are equal to each other. Over here, we're going to skip count by 10 on top. 10, 20, 30, 40, and 50, and by 24 on bottom, which would be a really big number. 24, 48 plus 24, 12, 72, plus 24, 96, plus 24, 90, 100, 110, 116, 120. All of these fractions are equal to each other. So, simplifying fractions. What is simplest form? Simplest form when the numerator and denominator have no common factor. That's what it means to be in simplest form. The numerator and the denominator have no common factor other than 1. Okay, so what that means is you keep dividing by numbers you can divide them both by until you can no longer divide them by any of the same number. Right? Let's look at that. So the first strategy is use the greatest common factor. Okay, we talked about the factors of numbers. So if I find the factors of both numbers, I divide them both by the largest factor they have in common. Okay, so if I look at the number 12, the fraction 12/18, we're looking at the fraction 12/18. Okay, what is the largest factor they have in common? If I do all the factors of 12, I have 1, 2, 3, 4, 6, and 12. 1 times 12, 2 times 6, 3 times 4. 18 has 1 times 18, 2 times 9, and 3 times 6. In both lists, what is the largest number they both have in common? And the answer is 6. That means I can divide both numbers by 6. 12 divided by 6 is 2. 18 divided by 6 is 3. All right, the greatest common factor. Okay, the other way we've done that is we keep dividing by what we know we can divide them by until we can no longer do that. Well, if they're both even, I can divide them both by 2. That gives me 6/9. Well, now the 6 and a 9. Well, I know that they're both multiples of 3, so I can divide them both by 3. and that gives me 2/3. You keep dividing until you can no longer divide them both, or you have prime numbers. How to simplify a fraction? Well, you find the greatest common factor of the numerator and denominator and divide both by that number, like we just did. So if I look at 3 and 12, I know that 3 is a prime number. So the only factors 3 have are 1 in itself. So I ask myself, is 3 a factor of 12? And that is true. That's absolutely correct. I know that if I count by 3's, I will say 12. So I can divide both numbers by that 3, or that 1 whole here. So 3 divided by 3 is 1. 12 divided by 3 is 4. So this simplest form is 1/4. So the greatest common factor example, 2/4. I can divide both numbers by 2 because 2 is a prime number. So I can't divide it by anything else. And 4 is a factor of 2, so, or a multiple of 2. So I can divide them both by 2. The answer there is 1/2. And we talked about this. If the number on top is half of the number on bottom, then it's automatically equal to 1/2, like 3/6, 4/8, 5/10, 6/12, and so on. And then strategy 2, using common factors, you can also change a fraction into simplest form by dividing by common factors. It may not be the greatest, but you keep dividing until you can no longer do that. If I look at this example, I know that 18 and 24 are both even, so I can divide them by 2. When I do that, I get 9/12. Well, I know that 9 and 12 both can be divided by 3, so I keep dividing. 9 divided by 3 is 3, 12 divided by 3 is 4. I know that 3 is a prime number, that's one of my superheroes, and it's not a factor of 4, so I know I am done.